Hey everybody, welcome to the Built Environment, Spring 2021. And this is the first part of the first lecture. And we're going to cover geography and geology. This is the first part of the course, which is all about mapping, and the readings relate to that. The first reading you're going to be doing, which is on Dropbox, is part of a book called Manhattan and Maps. So a lot of what we're looking at in the first lecture relates to the first reading. Let's see, let me share my screen. We're starting off with the most basic map that I could find. And I'm hoping that this is really obvious to you. This is New York City and the 5 boroughs. I hope you know where the boroughs are relative to each other. So this is number 1 here is Manhattan Island. And number 2 is Brooklyn. And I live right, where do I live? I live right in here somewhere, right there. Anyway, it's not important. And what's this over here? Everybody should know that. Of course, that's Queens. And up here is the Bronx. And down here is Staten Island. This is called, down here is the Lower Harbor. Those are supposed to be waves. This is the Inner Harbor here. Again, these are supposed to be waves. This is Governor's Island right here. Governor's Island is going to figure into some of the maps we're looking at. And let me get rid of all these squiggles here. Over here is New Jersey. And this, Brooklyn and Queens are part of which land formation? This is the end of what? That's part of Long Island, which continues. So that's something to know, right? And Manhattan is an island because it's, if you were to sail in a boat up the East River here, this is the Harlem River, and that separates Manhattan from the Bronx and from the mainland. So Manhattan is an island just like Staten Island is. The East River goes, if you go this way, you head toward Long Island Sound. And the East River is actually not technically a river, it's an estuary. And the tide from Long Island Sound goes back and forth up the East River. So the East River is salt water. And then over here is the Hudson River, which we'll talk about in the second half of this lecture. And the Hudson River is freshwater. There's freshwater coming down from upstate, but by the time it gets to the harbor here, these squiggles are kind of turning into a mess. By the time it gets down to the harbor, it's got a lot of salt in it. So in terms of size, so this is 2018 estimates of population. So you can see that the total of the 5 boroughs is over 8 million people, and Brooklyn and Queens are the 2 most populous boroughs. And Manhattan is in the middle. Manhattan and the Bronx are about the same size. And then Staten Island is much, much smaller in terms of people. So this is 2018. So the city has been growing gradually year by year, but now it's actually going down, the population. So going from 2018 to 2019, you can see that the populations have declined a little bit in all the boroughs. Oops. So this is 2018. The total population was 8,398,000, and then it's gone down by something like 50,000 people, something like that. And one would imagine that when we get the statistics for 2020, because of the pandemic, the population will have gone down even further. So after 20 years of solid growth, the city is beginning to lose a few people. I mean, it's still a gigantic city, but it'll be interesting to see what happens over the next 10, 20 years if the city gains population or loses population, or if it stays about the same. So that's population. So, but in terms of the size and area of the boroughs, that tells a completely different story. Queens is by far the biggest borough, 109 square miles. Brooklyn is number 2. Staten Island is number 3, 58 square miles. So Staten Island is, in population, barely has not even 500,000 people. But in terms of area, it's actually pretty big. And then the Bronx is 42 square miles, and Manhattan is the smallest of the boroughs at only 23 square miles. So in terms of population, Brooklyn and Queens are the biggest. And in terms of area, Queens and Brooklyn are the biggest, but Manhattan is number 3 in terms of population, but last in area. So let's really quickly, I don't want to spend too much time on this, but look at some types of maps of the city. The first third of the class is going to look at a lot at historic maps. So this is the kind of like tourist map that you might see with landmarks like the Chrysler Building and Empire State Building and Wall Street and the Statue of Liberty. This kind of like cartoon-like map with taxis and pizzas and stuff like that. Here's another version of a tourist map. And here's yet another version of a map of Queens, showing all the neighborhood names. And then this is one of my favorite maps of the city. This is from 1861. And this is showing Manhattan as the center of the world, which is pretty much what New Yorkers think of themselves, right? This is another important historical map from 1865. Egbert Vieli's sanitary and topographical map of the city. And this is showing all of the primordial waterways and hills and swamps underneath the grid of the city. This is another historical map. This is a fire insurance map. This is from 1852. These were issued in booklets, in big like folios, and they're remarkably detailed. They have every single building, and you can get information on what type of building it was. The pink means it's brick. The yellow means it's wood. And you can also get measurements and numbers of stories of buildings and things like that. So these are really useful for doing research, especially if you're an architecture student. So this is something that comes in very handy when you're researching a site in your studio courses. This is the Paris fire insurance maps. And these are, you can find them online on the New York Public Library website. And that information is in your syllabus if you want to look at these further. And this is a map that we all use every day, right? This is the Google map of the city. And then this is just the old school fold up Rand McNally road map of the 5 boroughs, which is great, if you get lost in the city. Last year when I taught this class in person, we did a project using these maps, but we're not going to do that this year. And this map we all know, right? This is a subway map that's constantly updated. And one thing about this map is that a lot of people don't realize that this is an abstraction of the city. This is actually not what the city looks like. Manhattan is way too big relative to the other boroughs. And it's kind of squished. Like Central Park is not that shape, that proportion. It's much longer and skinnier. And then here's a couple maps that are interesting, kind of specialized maps. This is a map that an artist named Kate McLean did in 2013. And what she's trying to do here is map different smells in Greenwich Village on a city block and come up with a graphic language for each smell. And you can see she has different, a key for different smells like wood, painting, bakery, coffee, and then she has urine, coconut, sewers and drains, etc. So it's kind of a whimsical attempt to map smells in a city block. But there actually is there's been more scientific attempts at mapping smell in the city. This is a map from, I'm not sure, this is like 1880s, I think. And this is a map showing the location of odor producing industries in New York and Brooklyn and part of the Bronx too. And what they're trying to show here is how industries affect people. So these are like an oil refinery here and a fat renderer, a phosphate works. And down here is an oil refinery, gas works over here, oil refinery. Here's a slaughterhouse. This is manure heaps, fat renderers, phosphate works. And they're showing how all the odors produced by those industries and float through the air to this neighborhood over here on the east side of Manhattan. And that's the affected area. So I think this was produced by the people who lived there, so it's claiming to be affected. So this was probably something that was used in a lawsuit. This is a satellite map, and from above showing the green areas are it's color coded. So the built up areas are in purple, and then the greener areas are green. So everything you see in green is either a cemetery or a park or woods, so you can see how much of Staten Island down here is still green, still woods, and how little of it in Manhattan is green, other than Central Park right here. And this is a kind of map that's produced with software called ArcGIS, Geographic Information System. And this is a really interesting, useful tool that you can use to generate all kinds of information on maps. So this is a crime map. This is showing crimes per 1,000 residents by police precinct from 2018 to 2019. So you can see which areas of the city have had the most crime. But there's all kinds of maps that you can do, and you can further search for crimes, for date, for type of crime. And GIS maps lend themselves to all kinds of applications for finding out things about the city, from historical information to like the dates buildings were built, things like that. This is a GIS generated map that just this is a screenshot from my phone. This is the kind of map that we're all looking at over the last year constantly to see the percentages of COVID in different parts of the city. So this is showing the percentage of people who have been tested, who have been have tested positive. This map is from about a week ago. So you can see the areas of the city that are most affected relative to other areas. And then I just want to quickly show you some maps that the second year architecture studio produced last fall using GIS, ArcGIS, to show different things about the city. The fall semester of second year studio spent studying New York and analyzing its neighborhoods. And so these are just some of the maps they produced using this tool, ArcGIS, hard to say. So really interesting. You also, for those of you who are in architecture, you'll also learn this tool in a class next fall called Site Tech. But this, these kinds of maps are really useful for architecture majors. And for non-majors too. I'm sure there's applications here in engineering, sociology, psychology, art, certainly. So here's one map student did of educational facilities and park space compared to how long it takes to walk to an educational facility. So you can start to learn things about the city by using this tool. These are a map that 5 of my students did, showing how their paths through their neighborhoods walking intersect with one another on the way to Corona Park in Queens. And then this is another type of map. This is also from our studio last fall, looking at mental maps. So maps that are constructed from one's memory. This is based on the book, The Image of the City by Kevin Lynch. So our second year students also built these maps from their memories of their pathways through the city. This is an interesting one. Some of our students also got into animation, so you can see the student animated here. Right here he is moving through his neighborhood and then also charting his the topography of his neighborhood up and down. So once you combine these types of map with animation as well, it can get really interesting. So I wanted you to see this just for those of you who are in architecture. This is something you'll probably do next fall when you're in second year. I realize some of you are in second year, so you already know that you've done it. So this is a map that is a hypothesis of what New York looked like before it was populated, thousands of years ago. This is part of the so-called Mannahatta project by a geographer named Eric Sanderson. And I wanted to show this to you as a segue into talking about the earliest history of the city, even before there were Lenape Indians here. I wanted to just get back to that point thousands of years ago and kind of build the course from the ground up, as it were, and start to talk about the bedrock geology and then move on to the colonial period. Move on to the Lenape Indian period and then the colonial period. So if you can imagine that this is what the city, before the city, this is what the land looked like before there was a city. It was woods and salt marshes. And then there was the Ice Age, the most recent Ice Age, like 35,000 years ago, something like that, where this entire area was covered with a glacier. Not this glacier, because this is a photograph, but this is kind of like what it might have looked like from the harbor. Oh, I said 35,000 years ago. Sorry, I meant 75,000 years ago. 75,000 to 11,000 years ago. So yeah, like 35,000 years ago average. For thousands of years, what is New York today was covered with a glacier, and it was called the Wisconsin Ice Sheet. And it looked something like that. So the entire northeastern United States was covered with this glacier. New England, upstate New York, New Jersey, all the way down to the ocean. And it was 1,000 feet thick. So for comparison, the Empire State Building is 1,400 square feet tall to the tip of its needle. And it's the actual occupiable part of it is 1,250 feet tall. So that means that if the Empire State Building had been here when the glacier came down from the north, not that it was, but if it had been, it would look something like this, approximately. So really thick sheet of ice. So the geology of New York is in large part defined by this glacier thousands of years ago, because it brought something to the city called glacial till. And glacial till is loose rocks, sand, gravel that are carried along by the glacier. So the glacier is going from north to south, and it has all these rocks frozen in it, and it's pushing them like a bulldozer in front of it. I mean, really, really slowly over thousands of years, but pushing it, carrying it, and then when it melts, this material is left behind. And what is today New York City is in large part defined by deposits of glacial till. And then there's also another type of a formation that's was brought by the glaciers called erratics. And erratics are bigger pieces of rock, like boulder-sized rocks that are deposited and then are left when the glacier melts. So here you can see two examples in Central Park, and they're sitting on top of bedrock, which we'll talk about in a second. And they're because they were suspended in ice, and then the ice went away, some of them are really huge, they're like the size of a minivan, and they're left just wherever they were. So sometimes they're left in these interesting positions. You can just see them in somebody's yard. There'll be a big boulder. You can see some yards out in Queens that they have boulders in them. Those are erratics. And in Central Park, you can see them. So the other formation, so there's glacial till, I want you to know. There's erratics, I want you to know what that is. And then the other thing is moraines. And moraines are kind of had the most influence on the topography of what became New York City. So if you can imagine that if the glacier is like a bulldozer in slow motion, I mean, over thousands of years, and it's pushing glacial till in front of it and on the sides, when it starts to melt and retreat, those piles of debris stay behind. And some of them are really immense, like they end up being the size of, not like a mountain, but the size of a good size hill, So the earth is pushed up in front of a glacier and then left behind when the glacier goes away. And those are called moraines. And there's a few types that I want you to know. So a lateral moraine, those are the piles of earth and rocks and gravel and other debris that are left on the sides of a glacier when it's melting. And then there's a recessional moraine, which just means a deposit where the glacier was before it retreated further. And then the very last moraine at the end, it would be called the terminal moraine, you know, the ending. So this is the terminal moraine down here, right? So that's the very last formation that the glacier made, and then it starts to retreat this way by melting, but it doesn't do it, you know, all at once. So at this point, the glacier maybe paused for a few thousand years or something, and then started retreating again. So it leaves another moraine that's called a recessional moraine. And then it keeps melting, keeps melting. And then these are the lateral moraines on either side, right here and here. And this is a terminal moraine here just because that's the furthest point that the glacier got. Had it continued, then there would be another moraine out here. Oh, I can't draw it there. Out here, and that would be the terminal moraine. So let's look at the satellite map again. So what's interesting is that even today, thousands of years later, you can still see the terminal moraines and the lateral moraines, and you can actually see where the glacier was. So this whole band of hills here separating Queens and Brooklyn goes down here, and then it goes across the harbor into Staten Island, and then up into New Jersey, something like that. Up here, like the Ramapo Mountains in New Jersey, and then, but down here, the middle of Staten Island here, that high point is part of the moraine. That's, I'm trying to think of the neighborhoods up there. Wagner College is up there. Tote Hill is a neighborhood up there. Grimes Hill, Emerson Hill. I don't know if any of you are from Staten Island, but. And then in Brooklyn, we have Greenwood Cemetery and Prospect Park. Those are part of the moraine. If you go hiking in Prospect Park and look at the soil, you'll see that it's like loose glacial till. And then there's this whole band of cemeteries here separating Brooklyn from Queens. Those are part of the moraine. Like, I think it's Calvary Cemetery. I can't remember all the names. And then there's a network of like parks and cemeteries here in Queens, also part of the moraine. And then if you look at historic maps, you can see it too. This is from 1776 during the American Revolution. And here you can see that formation of hills here. Eventually Prospect Park is going to be built somewhere in here. You can see that that's really a high point. That's why they built the park there. It has a nice Prospect Park. And eventually Greenwood Cemetery would be built there. So let's look at bedrock. So moving away from the glacier, let's look at the bedrock, meaning what was there underneath the foundation, geological foundation of the terrain, and then all the glacial till and the moraine and the erratics was deposited on top of it. But the bedrock is the bedrock. It was what was there before. And it was sculpted by the glaciers, but it was not part of the glacier. So there are three types of bedrock that I want you to know. The first is Manhattan schist. And you can see that in the city, especially in northern Manhattan, around City College. And when you go back next fall, you should go to, when we're back in school in person, you should go to St. Nicholas Park right outside the architecture school, and you can see schist. This is up in, this photograph is up in Washington Heights, I think, or maybe Inwood. And you can see these big formations of schist. And they go, you know, these are not just rocks sitting on, this is the earth. This is not just rocks sitting on top of the earth. These go really, really deep, really, really deep. And you can see it comes up out of the earth at places in the city. This is in Central Park. You can see a lot of schist outcroppings in Central Park. This is a popular outcropping called Rat Rock, which is in right near it's near Columbus Circle, right near the 59th Street entrance. This is a big outcropping of schist, and it's a popular hangout for climbers. It's really good to climb on. But its schist is also difficult to climb on because it's kind of sharp, because it has these little flecks of mica, which are kind of silvery. And when I was teaching this class in person, I had pieces of schist and marble and gneiss that I would pass around and stuff. But obviously we can't do that. But this close-up photograph can kind of give you an idea what it's like. It's very, it's gray, it's very rough, and it has these shiny sparkles in it that are mica. The second type of bedrock is called Fordham gneiss. G-N-E-I-S-S. It's pronounced gneiss. Gneiss, like schist, is also gray. They're often confused with each other, but you can tell gneiss because it often has these stripes of white rock interspersed with the gray rock. And you see gneiss a lot in northern Manhattan in the Bronx. So Fordham gneiss, you know, the Bronx. And then the third type of bedrock is marble, or Inwood marble. You see this most often in northernmost Manhattan, in Inwood, and in the Bronx again. And marble, of course, is a very white material, or sometimes yellowish. And it's, you get that, the formation of marble from the calcite grains, which are locked together. So gneiss and schist are both very hard and very durable. So both have been used for building buildings. Schist has been used for building a lot of stuff in New York City. It's good for building, and marble as well. But marble is very soft compared to the other two, and so it's susceptible to acid rain. So you see a lot of marble sculptures that have been kind of eaten away over the years. And this is a photograph of the Harlem River. So you can see in northern Manhattan, you can see sometimes entire outcroppings of marble. So this drawing, this is a section through Manhattan from south on the left to north on the right, going all the way from the Battery up to Midtown, like Herald Square, 34th Street. And this is showing this is a section cut through Broadway. So pretty much right through the middle of the island, showing you what the different soil formations are underneath the street, and the topography of the street as well. So there's one idea that has become really ingrained in people's idea of New York, which is that Manhattan is really flat. And of course it's not. Even in the lower parts, it's not flat. There's lots of hills still. So here you're starting from the Battery. Let me see. Here's a better view. So this is the Battery down here, right? And you start here and you're going uphill till you get to, it's kind of a plateau. And then City Hall Park is right about here. And then you continue, and then this dip down is to Canal Street, which is basically, you can see by Canal Street, you're at sea level, which is why Canal Street floods a lot. And then you start to go uphill again. And then I'll continue that in a second. And then you can see here, there's these deposits that are kind of in bands. This is all, so here we have sand, 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 quicksand, gravel. So that's what's going on down here. And all of those things, sand, gravel, those are all part of glacial till. So this is how much glacial till was dumped on top of the land. And then down here, you can see it says rock. That's the bedrock. So this is the bedrock at this point, schist mostly. And it goes deep, way down here at Duane Street, which is really weird. And then, so this is the formation of the bedrock. So all down here is bedrock, right? All of this is bedrock. And then just to continue, here we're going from, this is like Soho, going uphill to Houston, Bleecker Street. And so you can see what's happening is that the bedrock here is getting closer and closer and closer to the surface. Closer, closer, closer. And then here is at Union Square, you can see the bedrock is right at the surface. Then it starts to go down a little bit again. Oh, that's a blow up. Here's Union Square. Oops. And then it doesn't continue, but if it continued, you would see that the bedrock keeps going closer and closer to the surface. And then by Central Park, it's breaking out of the surface. And you start to see these exposed formations of bedrock. And that just continues until you get up by City College, where you see a lot of bedrock. And then in the Bronx, you see a lot of bedrock too. I think we're almost done. The last thing I wanted to tell you is that these three types of rock, schist, gneiss, marble, are all the same type of rock. They're metamorphic rock. So what is metamorphic rock? So it's granite, limestone, shale, those types of rocks that combine and change under pressure and high temperatures from ancient movement of the tectonic plates that formed and reformed the continent. So they're rock that has been changed under intense heat into something else. So, so that's bedrock. That's the end of the first part of the lecture. I just wanted to end with this image because, you know, especially in Manhattan, everything is covered with buildings and we forget that there's actually land underneath it. There's actually rock undergirding the whole city. And to build skyscrapers, any building, but especially skyscrapers, you have to deal with what's underneath. So in some of these cases, these skyscrapers were able to be anchored in the bedrock below. But in some places where the bedrock was so far beneath the surface, they have to just make do with the glacial till. And so they build foundations that are just stuck into the glacial till. But it looks like, you know, you see, if you fly over the city in a plane, you don't really, you're not really aware that it's kind of a landscape at all. It just looks like everything was built. But in fact, there's a whole geology below the city. Okay, that's the end of part one. So part two. So part two is recorded as well. And so you should watch that like right now, or you can watch it a little bit later. And in part two, we get into the Lenape Indians and Native American culture and early exploration and the formation of the New Netherland colony and the primary settlement, New Amsterdam. And we also start to look at some of the maps that you're doing from your first reading, Manhattan and Maps. So we look at the Manatus map. And then, so yeah, so watch the second half of the lecture. All right, thanks. Goodbye.